Today we will be doing October 2024 Math A Level P2. So the first question says, a continuous curve has equation y equals to f of x. A table of values of x and y for y equals to f of x is shown below. So the first part says, using the trapezium rule, with all the values of y in the given table, find an estimate for the below. So giving to one decimal place, we underline that because that's important. Then we know the trapezium rule will always be given in the formula sheet, which goes as so. 1/2 times the h times the first plus the last plus 2 times of all the in-between values. So y1 plus y2 plus y3. So the h is always the difference between these numbers, these x values. In this case, the height is 1.25 because we can do to find 1.75 minus 0.5, which gives 1.25. So finding that, we know 1/2 times 1.25 times first plus the last value plus 2 times of all the in-between values. And finding that, it gives us 30.878125, and to one decimal place that gives us 30.9. Part B says, using your answer to part A and making your method clear, estimate the below. So since we found the integration of f of x, which is right here, we only need to find the integration of 5.5 to 0.5 of 4x. You get x squared, and you have a 4, and you divide it by 2. Which gives us 2x squared, 5.5, 0.5, as such. And then we just need to add all that up, 30.9 plus 2 times 5.5 squared minus 2 times 0.5 squared. And that gives us an answer of 90.9. Now, question 2 says, we have a sequence of numbers u1, u2, u3, and it's defined by u1 equals to 7 and the below equation, where k is a constant. So we need to show that u5 equals to 7. How do we show that? We substitute to find u2 first. So u2 equals to minus 1 to the power of n, which is 1, times u1 plus k. That gives us an answer of minus 1 times u1, which is minus 7 plus k. Then we do the same for u3, which is minus 1 to the power of 2 times u2, which is minus 7 plus k plus k. That gives us an answer of minus 7 plus 2k. Then we do u4. And so on and so forth until we find u5. So in part B, we need to find the value of k given this. So we know that u1 plus u2 plus u3 plus u4 is equal to 30. And now we only need to substitute these values. This and this cancel out, this and this cancel out. We get 2k equals to 30, so k equals to 50. So this is a simple part. Only difficult thing was to figure out that this is a recurrent series, so with a periodic series with a period of 4. This is because on u5 is equal to u1. How many complete times every period appears is 37 times. And we know that the sum of u4 is 30, so 37 times 30. And 150 divided by 4 gives us a remainder of 2. So that means plus u1 plus u2, which gives us an answer of 1125. In question 3, we are giving the following function. F of x equals to 2x cubed minus x squared plus ax plus b. A and b are integers, given that when f of x is divided by x plus 3, the remainder is 55. This is a standard question. It will appear very often. So we know that if x plus 3 divides it, that means that x is minus 3. And the remainder is 55. So if we just substitute that in the equation, and then we find that answer, and when we rearrange this, it will give us 3a minus b equals to minus 118. Moving on to question B, given also that 2x minus 5 is a factor of x, find the value of a and the value of b. We can do the same thing, but setting this time the equals to be 0, and we find the second equation, and then we can solve them simultaneously. So in this case, we will substitute x with 5 over 2, and we get an equation of 2 times 5 over 2 cubed minus 5 over 2 squared plus 5 over 2a plus b is equal to 0. Substituting that, we get that. And if we rearrange this, we get 3a plus 118 equals to b. Substituting that with b, we get 5a plus 2 times 3a plus 118 equals to minus 50. So we get 11a plus 236 equals to minus 50. 11a equals to minus 286. And a equals to minus 26. And when we substitute a into the first equation, we can find b, which is 3 times minus 26 plus 118, giving us b equals to 40. Hence, find the quotient when f of x is divided by 7. This is simple long division. And we divide this by x minus 7 to find the quotient. First, to find the 2x cubed, we multiplied by 2x squared. That gives us 2x cubed minus 14x squared. Minus that, we get 13x minus 26x. That goes 13x inside minus 13x squared. Minus 91x. That gives us 65x plus 40. And that goes plus 65 times. So get minus 65x minus 455 times. And that gives us an answer of 495. So the full equation is this. This is the quotient. This is the remainder. But since they're asking for the quotient, we only state this. So question 4 is telling us the curve C has equation y equals to 4x to the power of 1 half plus 9x to the power of minus a half plus 3, where x is bigger than 0. The first part is asking us to find dy dx. Also another pretty standard question. That gives us 2x minus a half minus 9 over 2 minus 3 over 2. That is dy dx. Hence, find the x-coordinate of the stationary point of C. The stationary point is given when dy dx is equal to 0. So if we multiply all this by x to the power of 3 over 2, we get 2x minus 9 over 2 equals to 0, which is x equals to 9 over 4. Next, we need to find d squared y dx squared. That is just a second derivative, so that gives us an answer of minus x minus 3 over 2 plus 27 over 4x to the power of minus 5 halves. And we need to determine the nature of the stationary point of C. How we determine this? If d squared dy over dx squared is bigger than 0, then it's a minimum. And if the second derivative is smaller than 0, then it's a maximum. Using this, we can find the nature of the stationary point. We just substitute 9 over 4 into the equation, and we get an answer of 16 over 27, which is bigger than 0. So it's a local minimum. So we know since the local minimum is at 9 over 4, that means that it was decreasing all the way there. And we know that since the first x value is 0, because x must be greater than 0, we know that x 0 is smaller than x is smaller than 9 over 4 is a decreasing function. Question 5. We need to find the first three terms in ascending powers of x of the binomial expansion of 2 plus ax to the power of 6. A is a non-zero constant. So we need to use the choose terminology. That gives an answer of plus that gives us an answer of 64 plus 192ax plus 240a squared x squared. So in part B, we need to find the value of a given that the constant term in the expansion of f of x is 576. A constant term means is this the number without the x next to it. So first off, I'm gonna go ahead and find this. So that is 9 plus 2 times 3 over x plus 1 over x squared, which is also 9 plus 6 over x plus 1 over x squared. And so that times what we found here, we need to use this to find a, given that the constant term in the expansion of the following function is 576. So one constant term that can be found is the number times by the other number. Another constant term that can be found is the single x times by x to the power of minus 1. And another one is x squared times by x to the power of minus x squared, minus 2. So we find that 9 times 64 plus 192ax times 6 over x plus 240a squared x squared times 1 over x squared is equal to 576. All this will give us the constant term. So 9 times 64 is 576. Six times 192 gives us 1152, and that gives us 240a squared is equal to 576. Simplifying this gives us 240a squared plus 1152a equal to 0. Cancelling out the a gives us 240a is equal to minus 1152. So a is equal to minus 24 over 5. Question 6. Using the laws of logarithms, solve the equation. So one of the rules that we will have to use here is log of x base a minus log of y base a is equal to log of x over y base a. So if we go ahead and use that, we can find the answer to that question very easily. We know also that when we have a number in front of the log, we can move that number and put it as a power in front of the bracket of the log. Expanding that bracket, we get this. Then if we go ahead and use what we said earlier, we can finish off the question. Another law of the logarithm that we can use is that log of a base x is equal to b, so a to the power of b equals to x. Using that, we can say that 4 to the power of 2 is equal to 12 minus 2x over x squared plus 2x plus 1. So 16x squared plus 32x plus 16 is equals to 12 minus 2x. So 16x squared plus 34x minus plus 4 is equal to 0. If we go ahead and use the quadratic formula, we can find the value of x. From the quadratic equation, we find two answers, but we can only find one answer, so it means that we must have to reject one. In order to reject one, it means that we have to input x into each of the logarithms provided, and see if these give negative answer. If they give a negative answer, then they are rejected. If we input 1 over 8 here, it will give us a positive value. It will give us a positive value here also. If we input minus 2 here, it will give us a positive value here, but it will give us a negative value here. So it means that we must reject minus 2. So the only answer is x equals to minus 1 over 8. Moving on to question 7, it says, Jem pays money into a savings scheme, A, over a period of 300 months. Jem pays £20 into scheme A in month 1, 20.5 in month 2, 21 in month 3, and so on, so that the amounts Jem pays each month form an arithmetic sequence. So from this information, we can see that the difference between each month is 0.5 pounds. And we can also say that the starting value is 20 pounds. So from that, we can find question A, which says, show that Jem pays 69.50 into scheme A in month 100. So what we have to do here is find the 100th term and say U100 equals to A plus N minus 1 D. A is the starting value, which we found to be 20 pounds. D is the difference, 0.50 pounds. And N is the number of terms. So U100 will be 20 pounds plus N minus 1, 100 minus 1, which is 99, times by D, which is 0.5. And then when we calculate that, we find that that gives us a value of 69.5, as they wanted us to show. Part B says, find the total amount that GEM pays into Scheme A over the period of 300 months. So immediately when we see the word total, we know that we're dealing with the sum of the series. So we will use this equation. Both of these equations are given in the formula sheet. So then we just go ahead and plug in the numbers again, but this time the A and D are the same, but this time the N will be different because we are looking for 300 months. So the N will be 300. So we just go ahead and put that in. That will be 150. 2 times A, which is 2 times 20, plus 299 times 0.5. Finding that on the calculator, we get 28,425. We get 28,425. Moving on to part C, Kim pays money into a different savings scheme, B, over the same period of 300 months. In a model, the amount Kim pays into scheme B increases by the same percentage each month, so that the amounts Kim pays each month form a geometric sequence. Given that Kim pays 20 into scheme B in month 1 and 250 into scheme B in month 300, use the model to calculate to the nearest £10 the difference between the total amount paid into scheme A and the total amount paid into scheme B over the period of 300 months. So since we're dealing with a geometric sequence, we need to find firstly the R value, what does R mean? R is the common ratio, which is the constant multiplier between each term. So for example, between term 1 and term 2, it will be multiplied by R. Term 2 and term 3 again by R, and so on and so forth. So we need to find R. To find this, we will use the equation UN equals to A R to the power n minus 1. This equation is given, and we can use this information to find the value of R. So we know that when n is 300, the UN is 250, A is 20, from this here we know that, and we can say R to the power of 299. And then we go ahead and rearrange that. 12.5 is equal to R to the power of 299, and R, the root of this, and we can go ahead and find R by finding this root of 12.5. And R gives us a value of 1.008483032. And then to find the total amount of money paid over 300 months, we can use this equation now, and we can put the values that we already know in here and find Sn. And we find the value of 27,362.95. And then we go back and read again the question, and to see what it wants us to find. We need to find to the nearest £10 the difference between the total amount paid into scheme A and the total amount paid into scheme B over the period of 300 months. So we just go ahead and take this value away from this, and we find the answer, which is 1,062.051707 pounds. But we need to give it to the nearest £10, so it's 1,060 pounds. In question 8, we are given a graph, and it says figure 1 shows a sketch of part of the curve C1 with equation y equals to x squared plus 3, and part of the curve C2 with equation y equals to 13 minus 9 over x squared. In both occasions, x is bigger than 0, and we are also told that the curve C1 and C2 intersect at the points P and Q as shown in figure 1. Part A asks us to find the x-coordinate of P and the x-coordinate of Q using algebra. So how we'll do this? We will set the two equations to be equal to each other, because when they are said to be equal to each other, that means that they intersect. So if we go ahead and get rid of this x squared because we don't like it here, and multiply everything by x squared, we get x to the power of 4 plus 3x squared equals to 13x squared minus 9. Rearranging that, we get x to the power of 4 minus 10x squared plus 9 equals to 0. And if we go ahead and say that x squared is equal to a, and because this is a hidden quadratic equation, we can say that a squared minus 10a plus 9 equals to 0. And we can easily find the value of a, which is a minus 9, a minus 1. So a is equal to 9 and a is equal to 1. But we're not done yet, because remember we substituted x squared for a, so it's actually x squared is equal to 9, x squared is equal to 1. So x is equal to plus minus root of 9, which is 3. But we are told that x is bigger than 0 in both occasions, so we reject the minus, and we reject the minus here as well. So we are only left off with x is equal to 3 and x is equal to 1. Going to part B, the finite region R, shown shaded in figure 1, is bounded by C1 and C2. Use algebraic integration to find the exact area of R. So what we will have to do is find the integration of C2 from the value 1 to the value 3, and find the value of the integration of curve C1 from the same values, and we do C2 minus C1 to find the area of R, because the integration of specific x coordinates of one curve gives the area underneath that curve from those x coordinates. So to find the area beneath a curve or a line, we need to integrate it, finding the values that we want to find the area beneath. So in this case, the top value will be 3, because we found that they intersect at 3 and at 1. So we'll say the top value is 3 and the bottom value is 1. And we go ahead and integrate this curve C1 first. So how we integrate is we add 1 to the power and take it and divide by the new power. So we get x cubed divided by 3 plus 3x. If we go ahead and plug in the 3 and the 1, so we get 3 cubed over 3 plus 3 times 3 minus 1 cubed over 3 plus 3 times 1. We get 18 minus 10 over 3, which is the same as 44 over 3. And if we go ahead and integrate, do the same thing for curve C2, we integrate the same way. So if we go ahead and plug in the numbers again, 13 times 3 plus 9 over 3 minus 13 times 1 plus 9 over 1, we get 42 minus 22, which is 20. So we do C2 minus C1. This will give us the area of R. So 20 minus 44 over 3 gives us 16 over 3. In question 9, we are shown an equation 2 tan theta equals to 3 cos theta, and we need to show that that equation can be written as 3 sine squared theta plus 2 sine theta minus 3 equals to 0. So what we will do first, we will get rid of the tan and replace and use that tan theta equals to sine theta over cos theta. So we will say 2 sine theta over cos theta equals to 3 cos theta. We don't like this cos theta as a denominator here, so we will multiply everything by cos theta and bring that here. So we're left with 2 sine theta equals to 3 cos squared theta. So one identity that we will need to know is that sine squared theta plus cos squared theta equals to 1. So cos squared theta equals to 1 minus sine squared theta. If we go ahead and use that and put that instead of the cos squared theta, we get 2 sine theta equals to 3 times 1 minus sine squared theta. Expanding that bracket, we get 3 minus 3 sine squared theta. And bringing that all to the positive side, we get 3 sine squared theta minus plus 2 sine theta minus 3 equals to 0 as asked. In part B, it says, hence solve for minus pi smaller than x smaller than pi, the equation 2 tan 2x plus pi over 3 equals to 3 cos 2x plus pi over 3, giving your answers to 3 significant figures. We can use the answer that we found before, and this is a hidden quadratic equation, so we can say that sine theta is equal to a. So 3a squared plus 2a minus 3 equals to 0. And to solve this, we will use the quadratic formula, which is minus b plus minus square root of b squared minus 4ac over 2a. Putting in the values that we have, we get minus 2 plus minus 4 minus 4 times minus 3 times 3 over 2 times 3. We get minus 2 plus minus square root of 40 over 6. So a is equal to minus 1 plus root 10 over 3. And a is equal to minus 1 minus root 10 over 3. First of all, it's a good idea to write down the value of minus pi and pi in order to have values to compare with when we get the x values that we need. And so first we will say that since we substituted a for sine theta, but in this case theta is 2x plus pi over 3, we will say that sine of 2x plus pi over 3 is equal to minus 1 plus root 10 over 3. And also for the other value, 2x plus pi over 3 equals to minus 1 minus root 10 over 3. So to get rid of this sign here, we will do, and to leave this theta value alone, we will do 2x plus pi over 3 equals to shift sign of this value here. And that gives us a value of 0.804897. And if we go ahead and do the same thing for this value, we will not be able to obtain a value because this here is smaller than minus 1, and on the sine graph you cannot go below minus 1 on the y-axis, so shift sign of this will give us a math error, so we could just go ahead and delete this, and we are only left with this value here. So we can leave the x value alone, find the first of the x values. And the first value of x is minus 0.121. Remember, to 3 significant figures. Then there are some identities that we will need to know, 2 actually, which go like this. So if we replace these theta values in this and this, where k is any constant, like for example minus 1, 0, 1, or 2, we will get another x value or more than one x value. We'll do first with 2 pi k plus theta. When k is 0, we'll just be left with this value, which is theta. So we can try it with the value of k equals to minus 1. So we can say that 2x plus pi over 3 equals to minus 2 pi plus 0.804897. And if we leave x alone, we get x is minus 3.26, which is bigger than the pi, so that will be rejected. So we can go ahead and rub that out. Then we can try when k is equal to 1. So we'll get 2x plus pi over 3 equals to 2 pi plus 0.804897. And we rearrange x again, and we're left with x equals to 3.0223 significant figures, which is valid because it's smaller than pi. Then we can go ahead and use the other identity, which is 2 pi k plus pi minus theta. Firstly, we can try when k is equal to 0 here, so we will be left with pi minus theta. So we can just do that quickly. Pi minus theta, rearranging for x, 0.645. And we can also try for k equal to minus 1 in this equation. So it will remain with 2x plus pi over 3 equals to minus 2 pi plus pi minus theta, which is 0.804897 again. And rearranging for x once more, we get minus 2.50. These are the only values that you will get, so we can just go ahead and write them down. X is equal to minus 0.121, minus 2.50, 0.645, and 3.02. These values all fall within this range. So that's your answer. Question 10. We are told that the circle C has equation x squared plus y squared plus 4x minus 30y plus 209 equals to 0, and we need to find the coordinates of the center of C. So first off, I would just find the equation of circle C, because as is, it's not very tidy. So we will do completing the square for x and for y to get only two squared brackets for x, one for x and one for y, leaving us with some values that we will take over to the other side, which will be the radius squared. So if we go ahead and do that to make it more clear, x squared plus 4x is one thing that will be completing the square. Another is y squared minus 30y. And we can just go ahead and put the minus 209 on the other side because it's annoying us. So how we complete the square? We put x and take the sign in front of the x to the power of 1 constant. So the x to the power of 1 constant will just always be x. So we are always talking about this constant. And the sign in front of this number is a plus. So we will put a plus here. And the number here, we will put half of the constant in front of x. So it will be squared, and we'll square all that. And here, the sign will always be minus here. It does not depend on the sign in front of the constant of x. And we'll do minus, again, half of the constant in front of x. So it will be minus 2 squared. So if we go ahead and do the same thing for the y, we're gonna take this sign because now it's negative in front of the y. Halve the 30, get 15, square all that, and do minus the other 15 squared. And we set all that equal to 209, negative 209. Then if we take all the numbers to the other side, that becomes minus 209 plus 229. So that leaves us with 20. And to complete the question, in part I, it asks us for the center of the circle. The center coordinates are the number in the bracket and reverse the sign. So in this case, the center is minus 2, 15. And the radius, as asked in part II, is always this number here, the root of that number there. So in this case, it's root 20. In part B, we are told that line L has equation y equals to mx plus 1, where m is a constant. Given that L is a tangent to C at the point P, show that 2m squared minus 7m minus 22 is equal to 0. A tangent to a circle is a line passing through a point by only touching it and not crossing it. So in this case, there could be two tangents as such. So To show that, we'll go ahead and substitute y for mx plus 1 into the equation of the circle, which we found earlier to be this. So if we go ahead and substitute that, it's going to be x plus 2 all to the squared, mx plus 1 minus 15, so it'll be minus 14 all to the squared equals to 20. And we go ahead and expand that now. And we go ahead and add up all the numbers. It's going to be m squared x squared plus x squared minus 28 mx plus 4x plus 4 plus 196 is 200. If we take the 20 to this side, it's going to be minus 20. So it's going to be plus 180 equals to 0. And since we know that y equals to mx plus 1 is the tangent, there's only going to be one solution. And when there's one solution, the discriminant must be equal to 0. What is the discriminant? It is the b squared minus 4ac, which must be equal to 0. This, you can remember it as being part of the quadratic equation. It is the one inside the square root. So it's this here. If you can remember that, if you can remember it easier that way. So now we just have to go ahead and find the coefficients in front of x squared in front of x, since we know the coefficient for c. So in this case, it will be m squared plus 1 times x squared minus 28 m plus 4 x plus 180. And if we go ahead and put that in, we can show the equation we can show this equation here. So this is the b minus 4 times a, which is m squared plus 1, times 180 equal to 0. If we go ahead and solve this, we'll get 784 m squared minus 224 m plus 16 and minus 720 m squared minus 720 equals to 0. If we go ahead and simplify this, we get 64 m squared minus 224 m minus 704 is equal to 0. Since we need to show that the m squared coefficient is 2, we can just say divide this by 32 and divide all this by 32. And we get the wanted result of 2m squared minus 7m minus 22 equal to 0, as wanted. In part C, it says, hence find the possible pairs of coordinates of P. To start this, we can find the m we can just find this with brackets. It's pretty easy. We can do it also with the quadratic equation to check it if you want, but since it's pretty simple, we can just go ahead and find it pretty easily. So m is equal to 11 over 2 and m is equal to minus 2. Now that we found the m terms, we can go ahead and use this that we found here, which is the substituted equation of this, where we put this into this equation. So if we go ahead and use that again, we can just substitute the m values inside here to find the coordinates of the x, the possible coordinates of the x. If we go ahead and substitute first the -2, we get 5x squared plus -28 times -2 is 56, plus 4 is 60, so it's 60x plus 180 equals to 0. That's for one, and for the other, if we substitute 11 over 2 plus 1, that gives 31.25x squared minus 150x plus 180 equals to 0. If we go ahead and simplify this one here, we get x squared plus 12x plus 36 is equal to 0. Since it is a tangent, we will get a perfect square, so this is a perfect square here, which we can factorize to be x plus 6 all to the squared is equal to 0. So x is -6 for this one. If we simplify this one as well, we get it to be 25 over 4x squared minus 30x plus 36 equal to 0, which also comes out to be a perfect square of 5 over 2x minus 6 all to the squared equal to 0. So x is 12 over 5. So if we go ahead and plug in the x values into the equation that we were given above, y equals to mx plus 1. For this case of x, where x is 12 over 5, we used m to be 11 over 2. So we will say y equals to 11 over 2 times 12 over 5 plus 1. This gives us a value of y of 71 over 5. So 1x coordinate is 12 over 5, 71 over 5. And in this case, where we found x to be -6, we used the m value of -2. So we'll say y equals to -2x, which is times -6 plus 1, which gives us a value of 13, and another value of another coordinate of -6 and 13. These are the two answers for part C. Finally, question 11 says, prove by counterexample that the statement, if n is a prime number, then 3n plus 2 is also a prime number, is false. So when it says prove by counterexample, we can basically just try different n values until we show it otherwise, which will effectively prove it to be false. So the first prime number, we could start with n equals to 2, which is the first prime number. So 3 to the power of 2 plus 2 is 9 plus 2, which is 11. That is a prime number, so we can go ahead and try another value. For example, 3. 3 to the power of 3 plus 2 is 27 plus 2, which is 29. That is also a prime number. Then we can try n equals to 5. 3 to the power of 5 plus 2 is 243 plus 2, which is 245, which is divisible by 5. So, proven to be false. In part II, it tells us use proof by exhaustion to prove that if m is an integer that is not divisible by 3, then m squared minus 1 is divisible by 3. So proof by exhaustion is different from proof by counterexample, because when you prove by exhaustion, you need to show that for every value, every number that exists, that will be true. First of all, we need to think how we will define m in order for it to not be divisible by 3. So when you times any integer by 3, it's automatically divisible by 3. But if you times that integer by 3 and then add one number to it, add 1 to it, then it is not divisible by 3 anymore. So we can go ahead and say that m, for it to not be divisible by 3, we could define it as 3a plus 1. Then if we go ahead and put 3a plus 1 instead of m, and we expand this, we get 9a squared plus 6a plus 1 minus 1. Finishing that off, we get 9a squared plus 6a, because these two cancel each other out, leaving us with 9a squared plus 6a. If we divide all that by 3, if we factorize the 3 outside actually, we get 3a squared plus 2a. This 3 here means that this number will always be divisible by 3. Here we define that m is equal to 3a plus 1. So that will always be one number above a number that is divisible by 3. In order to get full marks here, we need to also consider the number that is one below the number divisible by 3. So we could define m to be also 3a minus 1. And if we put that also into the equation and we expand this, we get 9a squared minus 6a, because this again cancels out. And factorizing the 3 outside once more, we get something similar to the one above, where the 3 again means it will always be divisible by 3. Finally, we will just write a small sentence that when m is said to be 3a plus 1 and m is 3a minus 1, where in both cases number is not divisible by 3, the function gives a value which is divisible by 3, hence proven. That is the October 2024 paper. It was a quite difficult paper. If you have any questions, please tell me in the comments, and please also tell me what other papers you would like me to solve. Thank you.